Hello everyone. In this video, we are going to continue talking about similar triangles by using side-side-side and side-angle-side similarities. The first part of the lesson is about using similarity theorems. So first, let's talk about what these similarity statements tells us to do. So when we have two triangles that have the proportional side measures for all three of sides, then that means triangles are similar. Or if two pairs of sides from two triangles are similar and one included angle is the same, that means the triangles are similar again. So let's look at the first example. It says determine whether the triangles are similar. So for this, three sides are given. We need to see if they have the same proportion for the corresponding sides. So AC and DF correspond to each other. They correspond to each other. Let's see. 6/9 is the first ratio, and the next one is 8/12, and then the third one is 10/15. Now if we simplify these numbers, 6/9 can be written as 2/3. Divide each number by 3. For these two numbers, divide each one by 4, we get 2/3. For the next one, divide each one by 5, we get 2/3. Since these sides are having the same ratio, the figures are similar. So the triangles are similar. The reason is they have the scale factor of 2/3. The next example, determine whether the triangles are similar. So we have one included angle that is given, 70 degrees for the first triangle and 70 degrees for the second triangle. So angle N is congruent to angle R, and let's see if the sides are proportional. 3/4, this one right here, 6/8. So 6/8 can be simplified. Divide each number by 2, we get 3/4. This one was 3/4 as well, so they are the same. So for this one we say yes, because we have one pair of included angle congruent to each other and two pair of sides, here the first one, here the second one, that are proportional, and their scale factor is the same, which is 3/4. Here's the second part of the lesson, which is about using similar triangles. Let's get to work and then see the example right away. Triangle ABC is similar to triangle DEF. Find the values of x and y. So I'm trying to figure out the scale factor, and if I look at BC and EF, the year measure is given, which means we can write the scale factor. It's 18/9. This is the scale factor. It's equal to 18/9 or 2/1. Now, by using this scale factor, I can figure out the missing sides. So I know that AB and DE correspond to each other because AB is the first and second letters, DE are the first and second letters. So AB over DE must be the same as 2/1. AB's measure is given as y, DE's measure is given as 18. It's equal to 2/1. Do cross multiplication. Y times 1 is y, 18 times 2 is 36. So now we are going to do the same thing for AC and DF. So AC is proportional to DF, and the ratio must be equal to the scale factor. AC is given 18/3. DF is given as x, should be equal to 2/1 times these two and these two. So x times 2 is 2x equals 18/3. Divide each side by 2, we get x equals 9/3. For those who don't know how to get 9, we divide these two numbers because they are like terms. We cannot do 3/2 because 3 is under the square root, 2 is not. So 18 divided by 2 is 9. The sign between 18 and radical 3 is multiplication, even if there's no period, it means it's a multiplication. So the length of x would be 9 radical 3. Let's move on to the next example. This is the last one, by the way. Again, in the previous video, we had this type of example, and these are very common type of questions. So what we do is we write the scale factor by using these two sides. Because their measures are given, we cannot do the same thing with 6 and question mark because question mark is missing. So let's say this is x first. Now 1.5 over 7 is the scale factor, and it must be equal to 6 over x. Now if I do cross multiply, 1.5x equals 42. Let's divide each side by 1.5 to get x equals 28. So this is how tall is the flagpole. It's equal to 28 feet. That's all for this lesson, guys. Please comment below if you have any question. I will see you in another video, and thanks for watching.